Today we're going to continue looking at section 9.9, which is all about trig. We're going to find the missing sides of a right triangle, and we're going to find the measure of an angle in a given triangle. So here's our first example. We want to find all three trig ratios, sine, cosine, and tangent, given the diagram. So remember, when I want to find those ratios, we want to think of our special word, SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Notice that in the picture, they're giving us 2 out of the 3 sides. Well, if you notice that with this right triangle, we should be able to identify that third side without having to calculate anything. If you think about your Pythagorean triples, it's a 7, 24, 25 family. So now when it's saying to find all three trig ratios, this little measure right here, that angle is what they call theta. Sometimes there's an X in that spot, okay? But that's the angle that we want to focus on. So notice that 7 is the side that's directly across from that angle. So that would be my opposite side. 24 is one of the sides that forms the right angle. So remember, that's a leg. So 24 is then what we call the adjacent side because it's always the leg right next to the angle. Since 25 is across from the right angle, 25 is the biggest side. Remember, that is the hypotenuse. So now that I have everything labeled based off of that angle theta, we can find the sine of theta, we can find the cosine of theta, and we can find the tangent of theta. So once again, sine is opposite over hypotenuse. Opposite is 7, hypotenuse is 25. I cannot simplify that down any further. That's my answer. Since cosine is adjacent over hypotenuse, well, we labeled the adjacent side as 24. Hypotenuse is still 25. I can't simplify that any further. That is my answer. For the tangent of theta, remember, opposite over adjacent. Opposite is 7, adjacent is 24. I can't simplify that ratio. I have all three answers. Okay, in the next couple of problems, it's asking for us to find the measure of the angle, and we want to round the nearest whole number. So when they're asking just for the measure of an angle, we don't need to know all three sides of the triangle. What we need are just the 2 that are in the picture. So because we are dealing with the angle up here where that theta is, that's what I want to find. So we are going to have to think about our SOHCAHTOA. So we can set up the correct trig ratio. So notice that 7 is directly across. So we call that the opposite side. Notice 5 is one of the legs and it's right next to the angle. We call that the adjacent side. So because we are given the opposite and adjacent, if you look at SOHCAHTOA, that follows that third trig function, which is tangent. So we want to set it up as the tangent of theta, and that equals opposite, so 7, over adjacent, which is 5. Now that's what we did in our last problem, but we're not done now. To find the actual measure of that angle, we have to use our calculator. So remember, to find the measure of an angle, we really want that inverse tangent button. So in your calculator, it'd be second tangent. And then I want to do 7 divided by 5. And then once again, we are rounding to the nearest whole number. So in your calculator, hopefully you are seeing that we get 54.4623 and so on. But because that 0.4 is not going to be 5 or higher, that means that I get to let theta be 54 degrees. And that is my answer. So same idea then with the next one. We want to figure out what the measure of theta is. 2 is the leg that is right next to it, so that's adjacent. 7 is the side that's across from the right angle. That's the hypotenuse. So thinking about SOHCAHTOA, adjacent and hypotenuse means we want to be using cosine. So cosine of theta is going to equal my side of 2, which is adjacent, over my 7, which is my hypotenuse. Once again, that's not my final answer. To find the measure of that angle, we want to do that inverse cosine, and then 2 divided by 7. So once again, second cosine, 2 divided by 7. We want to round to the nearest whole number. So in the calculator, you should be getting 73.3984 and so on. So that 0.3 tells us that we want theta to stay 73 degrees. And there is my answer. All right, let's look at a couple of more. This time it says let's find the missing side. We're going to round to the nearest tenth. So in these pictures, they're giving us one of those acute angles, and they're giving us one side. So once again, we want to think about SOHCAHTOA. We want to use the angle that is given to us, so 50 degrees. So once again, when we're ever setting these up, we're never using the 90-degree angle. We want to use one of the acute angles. So I'm starting with 50 degrees, and I want to know, how does x relate? Well, notice that it's directly across. That makes x the opposite side. What is 3 in this problem? Well, it's across from the right angle. So that makes that the hypotenuse. So if I'm thinking about SOHCAHTOA, opposite and hypotenuse means we want to use sine. So we're talking about the 50-degree angle. So sine of 50 degrees is going to equal the opposite side of x over the hypotenuse of 3. To get the x by itself, I want to get rid of that division. To undo division means I multiply by whatever's in the denominator. So I'll multiply both sides by 3. That gets you x by itself, and that means that this whole thing is what I can very carefully type into the calculator. Because we're finding a leg, and remember your hypotenuse is the biggest side, we should be getting an answer that is smaller than 3. If we don't, then we're in trouble. But 3 times the sine of 50, rounding to the nearest tenth, remember, that's 1 decimal. So that means that when we're doing our rounding, we need to look at the second decimal. So I've got 2.29. So that second decimal of 9 tells me that the first decimal, we need to round it up. So x is going to equal 2.3. Once again, notice that I got a side smaller than my hypotenuse, so I know that that checks out. Looking at the next example, notice that we are given an angle of 18. I want to know the two sides. How do they relate to 18? So 4 is directly across. That makes it the opposite. Now, this is where you have to be careful. The side across from the 90 is the hypotenuse. That's not what x is. X is across from the other acute angle. It's right next to the 18. So that's the adjacent side. So just be very careful when you're looking at your triangles that you identify the hypotenuse correctly. So in this case, the hypotenuse is not being used. It's opposite and adjacent, which means we're thinking tangent. So it's the tangent of 18 degrees, and that equals opposite, which is 4, over adjacent, which is x. So once again, just like the last problem, I want to get rid of that fraction so I can get the variable by itself. But notice that x is in the denominator. I need to undo division, so I need to start by multiplying both sides by x. That will get rid of the fraction, but that doesn't quite get you x by itself. Because x is now being multiplied by the tangent of 18 degrees, we have to undo that multiplication. I'm going to divide both sides by the tangent of 18 to get x by itself. So 4 gets divided by the tangent of 18 degrees. So then we can carefully type that into our calculator. And once again, we're rounding to the nearest tenth, which means I need to look at the second decimal to tell me what the first decimal should be. So I have 12.31. So the 1 tells me that the 3 is going to stay the same, so 12.3 is going to be my answer. Okay, looking at this next problem, we are given a rhombus. The perimeter of the rhombus is 36. So let's start there. When you're given a perimeter, remember that means that all the sides add up to it. Well, when we have a rhombus, remember all the sides are congruent. So I want to take 36 and divide it by 4 to get what each side is. That means that each side is 9. They are telling me that the diagonal of AC is 10. So if this whole entire segment is 10, remember, we are going to cut it in half. Half of 10 tells me that this little piece and this little piece are both 5. Remember, when we have diagonals, they're always perpendicular in a rhombus. So we do have a right triangle. Notice that the angle that I want is labeled as X, so that's right here. So we need to look at the side of 5 and 9 in this triangle. Let me highlight this triangle for you in green. So this triangle right here is the triangle that we want to focus on. So we need to know, how does X relate to 5? Well, notice that's directly across. That's the opposite side. How does 9 relate in this problem? Well, that's actually across from the right angle. That's the hypotenuse. So once again, if we're thinking about our most famous trig word, which is SOHCAHTOA, I'm dealing with the opposite and the hypotenuse, so we're dealing with sine. So I want to set it up as the sine of X, because I don't know what that angle is, and that equals the opposite, which is 5, over the hypotenuse, which is 9. Once again, remember, to find the measure of an angle, we're not just hitting the sine button in our calculator. I want the inverse sine. So second sine, and then we want to take 5 and divide it by 9. And then we want to round to the nearest integer, so nearest whole number here. So if I get 33.7 in my calculator, that 7 tells me that we're going to round up. So that tells me that my value of X is really a 34-degree angle. All right, here's my next one. We are wanting to find X, which is another angle. Notice that in this particular problem, though, I don't see a right angle. So I cannot do trig until I get a right angle. So remember, that means we are going to drop an altitude, which forms right angles. Notice that the markings in this picture, that means that if one leg is 9, so is the other. So remember, this is an isosceles triangle, and what happens when you drop an altitude is it actually bisects that bottom. So 14 is going to get divided into 7 and 7. So now I want to know, how does 7 and 9 relate to the angle that we're trying to find? Well, 7 is one of the sides being formed by the right angle. It's a leg. That is the side that's right next to it, so this is the adjacent side. 9 is across from the right angle, so that is the hypotenuse. So once again, if I'm thinking about SOHCAHTOA, we are dealing with the adjacent and the hypotenuse, so that means we want to use cosine. So we would set it up as the cosine of X to equal, then we have our adjacent side, which is 7, over the hypotenuse, which is 9. But once again, to find the actual measure of the angle, we need the inverse button. So when we calculate it and we round to the nearest integer, second cosine of 7 divided by 9, we should get 38.9 in the calculator, which means that 0.9 is going to round up. So we are dealing with a 39-degree angle. All right, here is our, I believe this is our last one. So here we are given a rectangle. We want to find X to the nearest 10th. So notice that when we're given a rectangle, a couple of things we want to remember. We have right angles in a rectangle. Notice how there is a diagonal being drawn. So right now I see two different right triangles. Another thing to remember, though, is that opposite sides are congruent. So if it's 15 on the top, then it's 15 on the bottom. If it's x on the one side, it's x on the other. So then because I have that 23-degree angle, let's focus on that 23-degree angle in the bottom triangle, and that's how we'll be able to then solve for x. 15 is directly across from it, so that makes it the opposite side. X is the side that's right next to it. That's the adjacent side. So once again, if I'm thinking about SOHCAHTOA, we're talking about opposite and adjacent, so that means we're using tangent. So I'm setting it up as the tangent. Notice that we are dealing with the 23-degree angle. So tangent of 23 degrees is going to equal, once again, I want to do the opposite side. Oops. Ugh, sorry, give me a second. Okay, so we want to do the opposite side, which is going to be the 15, over the adjacent side, which is x. Oh, sorry, my computer is not cooperating. Okay, so over x. All right, so now I want to start solving for x. So once again, I got to get rid of that denominator. So I got to multiply both sides by x to get that fraction to go away. But that still doesn't quite get me x by itself. So now that x is being multiplied by the tangent, we're going to divide by the tangent of 23 degrees. So x is going to equal 15 divided by the tangent of 23 degrees. We can put that into our calculator exactly how we see it. And then once again, we're rounding to the nearest tenth. So that's one decimal place. So in your calculator, hopefully you're getting 35.33. I need to look at that second decimal to help me determine what the first one's going to be in my answer. Well, because it's a 3, that means that I get to leave that first decimal as a 3. So this would be the length of the side. Okay, so that is us finding the missing sides of a right triangle and finding the measure of an angle in a given triangle.